Today's lesson will focus on some of the basic uses of graph. We will be going through 3 basic points, including plotting coordinates, editing the graph, and drawing trend lines. Graph is an open source application used to draw mathematical graphs in a coordinate system. Anyone who wants to draw graphs of functions will find this program very useful. The program makes it very easy to visualize a function and paste it into another program. It is also possible to do some mathematical calculations on the functions. As you can see from this illustration, graph is divided into 3 parts. On the right, one can find the plotting area. At the top left corner, one finds all the formula used to draw these graphs. At the bottom left corner, one finds some calculations related to graph theory. I will be talking about these 2 sections in a few minutes. At the bottom right corner, one finds the x and y coordinates, just where the cursor is. At the top, one finds some common toolbars, such as the File, Edit, and Help tabs. There are also other tabs related to this program that are the Function, the Zoom, and Calculation tabs. Beneath these tabs, there's a full row of icons that will facilitate our working. We are now going to show you how to start using this program. The first thing one usually learns is how to plot a graph. Graph helps you insert a point series and plot it automatically to see the end result. Just follow the following simple steps. The first step is to press the icon labeled Insert a Point Series as shown by the cursor. Please note that this icon is only used when one has a set of coordinates and needs to display the graph. As you can see, a new window appears. Here one can insert values of x with the corresponding values of y. It is important to know that here you are not allowed to insert an equation that will compute the value of y. There is another way to work with equations. After inputting the x and y values, one can choose to arrange the marker, lines, and labels as required. In this case, I am changing the color to black in the marker section and removing the plotting line completely through the style insertion in the line section. The sample section will show you what the graph will look like. After selecting your preferences, press the OK tab at the bottom. After pressing the OK button, one will see his coordinates plotted onto the graph. In my case, not all the points are within the range, but this is not a problem. As you can see, the graph has to be amended so that all the points fit on the screen. To fit the points into the screen, one can make use of the icons shown by the cursor. These include the Zoom In button, the Zoom Out, the Zoom to User Selected window, and the Move the Coordinate System with the mouse. Using any of these 4 buttons, one can modify the graph to fit into the screen as I am showing. The illustration here shown is the end product after editing. Adding a trend line is one of the useful functions found in this program. As you know, a trend line is the best line which fits the plotted data. By right-clicking on the series 1, one can insert a trend line of their choice by choosing Insert Trend Line from the drop-down menu. On pressing Insert Trend Line, one finds various types of trend lines, the most common being the linear and the polynomial. The next step is to try and find the best straight line that can represent our points. For the purpose of this explanation, let us choose 3 different lines: the linear, the logarithmic, and the polynomial. As we have already said, our task is to find the trend line which best fits our plotted points. This is easier done by switching each line off. We can do this by clicking on the Very Good button next to the equation pertaining to each line. These equations are found at the top left corner. Please observe the procedure attentively. We can see that the best trend line that fits my data is the polynomial of order 3, also known as cubic equation. This is in fact the black line, and the only line which we will leave switched on in this case. Let's go back once again to the top left corner. At the top left corner, please note that for each trend line inserted, the program has also automatically calculated the equation of the line. The value of r squared at the end of each equation represents the degree of accuracy. The closest the value of r squared is to 1, the more accurate it is. The cubic equation proves that the chosen polynomial is in fact the best line that fits the jotted coordinates. This is the end of part 1. Part 2 will take us through other useful features of this program.